and this is connected across a potentiometer wire AB. Suppose this is the wire AB, whose length L given to us is the value of potentiometer, the length of the potentiometer wire given to us is 10 meters, and a resistance associated with this potentiometer wire. We can, what this means is that we can think of a potentiometer wire as a resistor, okay, the entire length of potentiometer wire as a resistor whose value given to us is 30 ohms. Okay. And as we can see, all these resistors are connected in series with each other. Okay. Also, one more thing is given to us is that if the fall of potential along the potentiometer wire, the fall of potentiometer along the fall of potential along the potentiometer wire suggests the change in the potential with the change in the distance. That means the parameter which is given to us here is same as potential gradient. Okay, so the potential gradient which is given to us is 50 microvolts per millimeter. So if we will use the SI system, so in SI systems we can write this as 1 micro represents 10 to the power minus 6, and 1 millimeter is 10 to the power minus 3 meters. So this would be in terms of volts per meter. Okay, so this represents the potential gradient. Now we know the value of potential gradient. Okay, we know the length of the potentiometer wire, the resistance associated with the potentiometer wire, internal resistance, and the EMF of the cell. The thing which is unknown to us is the external resistance RH. Okay, so what we can do here is we can use the formula for the potential gradient. Now, as we know, the formula for potential gradient, as we have seen earlier, the potential gradient is the voltage, the potential difference between the points A and B divided by its corresponding length. Okay, so in terms of by Ohm's law, we can write it as I R by L, where I is the current flowing through the circuit. Now, in place of the current we can write it as, by Ohm's law, it is the total voltage in the circuit, EMF, divided by the total resistance in the circuit. This is I times R by L. Okay, so this is the value of the potential gradient. Okay, now if we will solve for this potential gradient, we can get the value of RH. So let us solve for this expression for K. Okay, this K is equivalent to, from here we can see that K is equivalent to E by R plus. So if we will substitute for the value of K, here we can write 550 into 10 to the power minus 6 divided by 10 to the power minus 3 is equal to E, EMF of the cell which is given to us is 2.5 volts divided by the total resistance of the circuit. The value of the resistance of the potentiometer wire is 30 ohm. So this is 30 plus the internal resistance is 5 ohm plus the external resistance RH times R by L. The resistance of the potentiometer wire 30 ohm, but by the length of the wire is 10 meters. Okay, so if we will solve for RH, okay, after solving for RH, we will be getting it as this could be written as 50 into 10 to the power minus 3 is to 2.5 into 3 divided by 35 plus RH. Okay, so from here 35 plus RH is same as 35. So this is equal to 150. Okay, after solving this, we'll be getting 150. So from here we can see that RH is 150 minus 35, which is 115 ohms. Okay, so this is the value of the external resistance which is connected in series with the internal resistance and the potentiometer wire, okay, for which the potential gradient in the circuit is 50 microvolts per millimeter. Okay. Now, after seeing the potentiometer and the applications of potentiometer in determining or in comparing the EMF of the cell, we can compare the potentiometer with a voltmeter. Now, what are the differences in a potentiometer and a voltmeter? Now, voltmeter, as we know that voltmeter is a device which is used to measure the potential difference between the 2 points. But actually, voltmeter can't measure the the actual voltage, actual potential difference between the 2 points. For example, what I mean is, suppose we will consider a circuit. Okay. suppose we consider a circuit containing an EMF with some internal resistance E and R. Okay, and we want to measure the potential difference between these 2 points. Suppose it is connected to some conductor. Okay, we need to measure the potential. Okay, potential see, this is the EMF. You can say that this is the EMF of the cell containing this is the cell containing the EMF and the internal resistance. We need to measure the potential difference between these 2 points. Okay, so what we can do is we can connect a voltmeter across this cell. Okay, so if we will connect a voltmeter across this cell, okay, suppose this is a voltmeter which is connected across the cell. Now, because of the internal resistance present in the circuit, okay, and because of the EMF, the source, okay, we'll be having some current. Because of the source, we'll be having some current, and because of the presence of the internal resistance, there would be some potential drop. Okay, potential drop across this resistor R. So that means the voltage which will be measured between the 2 points of the cell is not E, but it is something like E. If we will see here, that would be E minus. Okay. See, E represents the EMF of the cell, and R is the internal resistance. And suppose let us assume that the current which is passing through the circuit is I. Okay, so there is an potential drop of I into R. Okay, that means V would be something given as E minus IR. So this is the potential drop which is occurring across the internal resistance. Okay, and we are not able to measure the actual value of the EMF of the cell. Okay, what we are measuring is the EMF of the cell minus the potential drop across the internal resistance R. Okay, so that is what we measure in a voltmeter. Okay, now if we will use a potentiometer to measure the potential difference between the cell or the potential difference across the cell, what we will be getting is, like suppose if we in place of voltmeter we have connected a potentiometer. Okay, suppose for this case I represent a potentiometer by a symbol P. Okay, now this represents a potentiometer, and this is used to calculate the potential drop across the EMF across the cell. Okay, now as we have just seen, as per the principle of potentiometer wire, okay, the potentiometer is based on null deflection method. That means a galvanometer, it contains a galvanometer which the jockey is placed across the potentiometer wire such that there is no current from the cell. Now since there is no current from the cell when a potentiometer is connected, for the null deflection case there would be no potential drop across the resistor. That means the potentiometer will measure, suppose P represents the voltage that is measured by the potentiometer, that would be same as E. Okay, there would be no potential drop across the internal resistance, because in the null deflection method, as we have seen in the case of potentiometer wire, there is no current which is passing through the circuit. That means a potentiometer wire can be used to measure the actual EMF of the cell, okay, irrespective of the value of the internal resistance of the cell. Okay, so this is one of the advantage of using potentiometer over voltmeter. The other advantage is that voltmeter is not as sensitive. That means it can't measure very minute or very small EMFs. Whereas a potentiometer can be used to measure very small EMF of the cells. Okay, and we can also increase the accuracy of a potentiometer. We can further increase the sensitivity or accuracy of a potentiometer by increasing the length of the potentiometer wire. That means if we'll increase the length of the potentiometer wire, we can increase the sensitivity. That means we can increase or we can measure a EMF which is very small. Okay, okay, and one more advantage, as we have seen, that since voltage draws some current from the source of EMF, this is not this is not as versatile as potentiometer, because it doesn't draw any current from the cell. Okay, so it can be used to measure the actual EMF of the cell. So these are the applications, these are the advantages of potentiometer over a voltmeter. But still there is one disadvantage of potentiometer, is that the device is not portable as in comparison to a voltmeter. Okay, so voltmeter, the advantage of voltmeter over potentiometer is it is more portable. It's much easier to carry a voltmeter rather than a potentiometer. But if we want accuracy, we can use a potentiometer instead of voltmeter to determine the value or to compare the EMF of the cells.